The Tektronix innovative TICP series IsoVu isolated current probes are specifically designed for making a wide range of current shunt measurements with high bandwidth and low noise. They can make measurements from microamps to hundreds of amps depending on the connected shunt. Unique RF isolation helps protect the equipment and personnel from high voltages and enables outstanding common mode noise rejection. Clamp-on probes are often used for making current measurements. They deliver excellent performance for mid-range currents, but due to their reliance on magnetics, they fall short for low current measurements with high sensitivity or high current measurements at high bandwidths. Rather than using magnetics, the TICP series measures the voltage drop across a series shunt resistor and converts it into a current signal based on Ohm's law. While you might be tempted to use a low voltage differential probe for measurements on the shunts, differential probes have lower common mode rejection and higher input impedance, which impacts noise and accuracy. The TICP IsoVu isolated current probes come in 3 different bandwidth models: 250 MHz, 500 MHz, and 1 GHz.
The isolation barrier enables CMRR of up to 90 dB at 1 MHz to minimize the common mode noise interference, which is especially troublesome in power systems. Low attenuation and low input impedance makes these probes ideal for measuring voltage across the shunt resistors, contributing less than 150 microvolt RMS noise even at 1 GHz.
The probes are compatible with 4, 5, and 6 series MSO oscilloscopes. Once connected to the scope, the TEC-VPI interface detects the probe and the tips and automatically configures the scaling and channel settings. This helps minimize setup time and makes it easy to integrate the probes into automated test environments. To handle a wide range of current measurements, the probe comes with different attenuation tips and adapters. The 1x and 10x MMCX tips are included in the standard package along with an SMA adapter. For applications that require higher attenuation, an optional 100x tip is available. All these tips are designed for flexibility with a low bend radius to help minimize force on the DUT. Each probe comes with a bipod and a tripod adapter to firmly position the probe. The unique tripod adapter design lets you mount the probe without having to disconnect the probe from the test setup. The tips connect to the probe body without having to worry about orientation. They use off-the-shelf, high-performance MMCX connectors to attach to onboard shunts or CVRs. Let's look at a high-voltage double pulse testing application. In this application, the probe's isolation and 1000-volt Cat2 safety rating help protect the user from high voltages along with a proper enclosure. For this example, I have a setup here for running double pulse tests on this silicon carbide half-bridge evaluation board. We'll make an isolated source current measurement on the high side FET. This eval board operates at DC bus voltages up to 800 volts. Because the TICP probe is isolated and rated at a 1000-volt Cat2 isolation, it can make this measurement with a high degree of safety and protect me and the test equipment from high voltages. Based on the design and circuit parameters, I'm expecting to see about 100 microjoules of switching loss as the high side FET switches on and off. The board has 2 CVRs on it. I've connected a TICP 100 on the high side source current. Since I'm expecting to measure current in the range of 7 amps, I have a 1x attenuation tip for this purpose. It also has banana jacks for connecting a high voltage differential probe to VDS. I've connected a THTP 0200 to the high side FET. A TIVP isolated voltage probe is connected to the high side gate for making clean measurements of VGS. I'm using a 5 series MSO with WBG DPT double pulse testing software. Let's start the double pulse test. After triggering the double pulse test, you can see the switching measurement looks great. We got about 100 microjoules, which is what I was expecting to see for this eval board. I also have some results here from another power supply eval board. This one uses GaN FETs. With a 10x attenuator tip, I can use the TICP to look at VGS on the high side FET. With the differential probe, we see a lot of common mode interference across the gate resistor as it switches. You can see that here. The IsoVu current probe has much higher common mode rejection. The TICP can be used to measure VGS, but it is not a high impedance probe. The IsoVu voltage probe also has exceptional CMRR, but it also has higher input impedance. This makes it a better choice, especially with higher value gate resistors. The TICP current probe is also a great choice for measurements on low power mobile and IoT devices. Some power rails are moving to 48 volts and traditional differential probes don't have the common mode voltage rating for these applications. This time, we are using a handy bipod which is included in the standard package. I'll connect the current probe to a shunt on the 3.3 volt processor power rail. I can reset the processor and see the dynamic current draw as the processor wakes up, accesses I/O and memory, and goes back into hibernation. The bandwidth and sensitivity of the TICP lets you see exactly what the processor is drawing. With high bandwidth and complete galvanic isolation, the IsoVu current probes enable you to make more accurate dynamic current measurements on your 4, 5, and 6 series MSO oscilloscopes, allowing you to go beyond traditional current measurement limits.